Welcome to Black and Psych, and thank you for coming to our event today. Who is Black and Psych? Black and Psych is a platform to promote visibility, community, and networking opportunities between Black professionals and trainees across the field of psychology. We seek to celebrate, amplify, and support Black voices in psychology and to encourage dialogue around the intersections of psychology, race, social justice, and equity. What we are here for. The Black and Psych organization is founded to one, promote the visibility of Black professionals and trainees in the field of psychology, two, create a community and network of established and aspiring Black psychologists for connection and future collaboration, and three, encourage and hold a space for dialogue around the intersections of psychology, race, social justice, and equity. Who we are here for. Black and Psych is founded to promote visibility, community, and networking opportunities between Black professionals and trainees across the field of psychology, inclusive of all intersectional identities. This is Black and Psych's current team, and you're currently hearing from the current president, Lauren Kendall Brooks. If you're interested in joining our team, please send an email to blackandspsych@gmail.com, visit our website at blackandspsych.org, or follow us on Twitter or Instagram. Also, the QR code listed on the right side of your screen will also take you directly to our website. Thank you, and I hope you would really enjoy today's seminar.
Okay, let's go. Welcome everyone. My name is Jocelyn Roche Hidalgo. I am the Director of Finances for Black and Psych. I just wanted to talk very quickly about who is Black and Psych, what is Black and Psych. So Black and Psych is a platform to promote visibility, community, and networking opportunities between Black professionals and trainees across all the fields of psychology. So this summer, we organized a series of workshops and talks focused on data visualization. We first had general speakers about what we should do as scientists and trainees in the field to communicate science. And now this month we had wonderful Ketura Elie helping us and showing us how to create data visualizations using what I think it's a very cool tool, R. And we had a first part a couple weeks ago, and this is a continuation of that talk. Upcoming next month, we're going to have another talk focused on SPSS and more specifically using SPSS for meta-analysis and how you can use this tool for data visualization like forest plots and things like that, specifically on meta-analysis studies. So yeah, without further ado, I will welcome Ketura Elie and her wonderful talk. And thank you so much for being here. Feel free to share it with everyone right now. The talk today should be around 2 hours, 2 hours and a half. So feel free to let people know and they can join anytime throughout the talk. But thank you.
Thank you for that welcome again, Jocelyn. Hi, everybody. So like Jocelyn mentioned, this is like part 2 of a workshop on visualizing in R. And really quickly, I'm going to launch a survey, just asking if people are coming back from part 1, if they had a chance to look at the take-home worksheet that was supplied. Because I kind of want to start off with just a brief review of what was covered before. So if this is your first time, then that could be really helpful before we launch into like the more advanced sort of plotting techniques as a basic of plotting in ggplot. I'm going to give like maybe 2 more minutes, 2 to 3 minutes to complete the poll, and then we'll start. Okay, so it looks like I'm gonna end the poll. Thank you everyone for participating. But it looks like we have some people coming back, some people here for the first time. So I am just going to just quickly kind of go review the basic of what was covered last time, just because I'm going to be using the same terminology for the second part. And so if, regardless if you're here first or second time, to start, when I approach plotting with ggplot, I do like to use the grammar of graphics, as they call it. And so I am a true believer of this outline, where for any fundamental basic plot, you're going to need your data, of course, understanding aesthetics and geometries. And so data is self-explanatory. It's usually the file that you read into R. Aesthetics can get a bit tricky, but it overall refers to the variables that you are mapping or that you want to display. And so when you go to create your plot using geometries, which is a way to reference of how your data is going to be displayed, the aesthetic refers to essentially the variables that you see. And so in this simple example, our aesthetics are X and Y that are highlighted in these purple and blue yellow boxes to show that we are displaying these two variables as points or a scatter plot. And lo and behold, this geometry would be referred to as a geom point. And so last talk, that's basically what we covered. Going over again the basic grammar structure I like to refer to for ggplot, where first we always start with our data, and then we get to what we call a parent call, and that's essentially just the basic of what you are plotting, and it is the first call to ggplot. So the actual function ggplot, and again, we are mapping our aesthetics, meaning we're pulling X and Y from our data to display. And then the final element of completing the basic plot is finally adding our geometries. So how is our data going to be displayed? And here, this is creating a scatter plot. And so this is what it looks like. And these slides are up in the repository for this workshop from day one. And so all of that resource is available there. And then the resources from today will also be uploaded to that repository. Okay. And after we kind of covered, the basic elements, we went over what it means to change your plots manually. So here I am manually coding or changing my points to be blue. Here I am changing it to be purple. However, we can also use aesthetics to also change what our plot looks like. And again, the big thing about aesthetics or this AES function is that it is referring to the columns of or data or your file. And so here, I want to change the size of my points, but I want it to mean something. I want it to reflect the values of X in my data set. And so when I do that, you'll see that now we don't have just regular points. There is a meaningful meaning behind this, and you'll see that R will create a legend for us to indicate the larger the size of our plots indicates larger values of X, and you can see that as we go from left to right on the X-axis. And so this is not only a good way to, visualize more of your data, but sometimes we want to visualize just more than two variables. Although here I am just still using two variables. And so making more layered plots, more complicated plots requires this understanding that you can change various things about your plots to reflect more variables in your data. And then finally, we covered facets and themes, and facets are, again, another way to sort of display things about your data. And here we were working with the Anscombe data set. And the reason why I like working with this data set is because if we were to just plot X and Y, this is the relationship that we would see. We might draw a different statistical conclusion about this if we ended our visual exploration there. However, with the use of facets, we can actually see there are various different relationships between X and Y depending on the data set that are from. So again, similar in the same vein that aesthetics can be used to display more variables, facets can also be really important in exploring your data and seeing what is the relationship that is happening in my data set, and is what I'm seeing truly what it is, or is there something underlying beneath it? And then we ended with themes, which is basically a way to customize plots. The functionality of this is, broadly communicating in terms of like, can people read your plot? Do you have your axis labeled? Are you satisfied with it? Or maybe journals, want plots to be look aesthetically in a certain way. And so themes is really a way to get at that part, although there are some packages not discussed in this talk that will spit out publication ready plots for you. However, I still think that understanding the basics of how ggplot works really helps in using those additional packages as well. Okay. If I'm talking too fast or if there's any questions, please feel free to interrupt me at any time. But that was really like a brief overview of what was covered. Again, all of this material is available on the GitHub repository, and I know that the first workshop was recorded as well, so that'll be there. So for this talk, we're going to do a more in-depth exploration of visualization techniques. And really that is what I would classify as things that I know people Google a lot or they search a lot, and it's just hard to find, hard to understand, just because maybe Stack Overflow does have your answer, but it doesn't necessarily explain what's happening when you use this line of code or what's happening with your plot. And so here we're going to, again, cover the basic, because it all comes back to the basic foundations of ggplot, data, aesthetics, and geom. And we'll briefly cover bar graph, histogram, box plots, and then also talk about customization. So here, this is how you put a custom color, how you put a custom fill. We're going to talk a bit about factors and what that means in ggplot and why it's important, and cover a little bit more about themes if time permits. And so I kind of want to, oh, and I should mention that this workshop specifically is going to be very hands-on, so like more live demonstration than slides. So if you want to follow along, and pull up a blank markdown to kind of take notes as I also type along. I'm really self-conscious about typing in front of people. Like, I think coding in front of an audience is always so nervous, but if you want to follow along, feel free to do so. But that document is also going to be available, so you don't need to take extensive notes at the moment, but I think it would be good practice to sort of do a follow along. Okay, so to kind of start this, I want to talk a bit about factors specifically. So in the first talk, we kind of went over how understanding your variable type. So, when you read in your CSV file, exec file, how R recognizes this column. Is it numerical? Is it categorical? Is it a character? That has important implications for how you go on to visualize that variable. And a special variable that R gets specifically is factors. So you can think of factors, for example, say I had a variable that was shapes and I have 3 types of shapes, square, circle, and a triangle. If I wanted, and say I just had like a count of this is how many squares I have, this is how many circles, this is how many stars. If I wanted to visualize this in a way, say create a bar plot of these counts, R would need to recognize this variable as a factor. And an easier way to explain this or to understand this is to just think of it as a category. So similar to how we have race categories, gender category, political affiliation categories, they're not necessarily numbers. And so this is not something that's going to be plotted in a continuous fashion. It is a category. So, but we can't also consider it a character. Because if you've ever done anything with text, that is also something that R recognizes. When I pull up the coding demonstration. Hopefully this will make more sense. But when we are thinking of anything that you have that is a categorical variable, it's important to understand that for plotting purposes, visualization purposes, R will need to recognize it as a factor in order to accomplish the visualization that you want. And then again, sort of as a preview, we're going to cover three plots that I think are commonly used, especially in psych research, because you already covered scatter plots. So we can also kind of review that again later on if people want to see that, but want to focus on bar plots, histograms, and box plots. And for all of these, it is the same kind of fundamental basis where we're going to have a data, we're going to have our aesthetic, and then we're going to have our geomes. And by the name of the plots, it's pretty straightforward what the geome is. So for bar plots, we're going to use geome bar, histograms, geome histogram, and box plot, geome box plot. And so now I will be sharing my R. If I can find it. Okay, can everybody see my screen? And it should be a blank screen. Thank you for the thumbs up. Okay, so for this demonstration, we're going to be working with the penguins data set. And so if you don't, first, before anything, I want to install tidyverse. It should be working, and this is just to get ggplot. But for the penguins data set, if you don't have it already, this is the library that it's part of. Oh, I don't know why. Let me make sure that my install. Okay. Okay, I already have that package in. So that's why you see that. So we're just going to ignore that and then go straight to the library. Okay. And really quickly, whenever I load in a data set, I like to look at it. So you could either use head or glamps. And this just gives you, here are my columns. Here are some values. We see some NAs here and there, but that's not really a problem for now. And again, something else that I like to do, usually, as researchers, you typically know what your variable type is, but to just double check that R is recognizing it in the same manner, you can use the structure function to see, okay, species, again, here is that special variable type we're talking about. R recognizes as a factor, so does island. We have some numerical variable types, integers, as well factors, and then another integer. And so going to this factors conversation, if we look at what species is, again, it's just a category. So these are just different species of penguins. And if I wanted to look specifically at what all those levels were, I could select species. And then look at the level. So I have, and structure also tells you, so you have factor with 3 levels, and that just means you have 3 different categories under this umbrella variable of species. So we have 3 different species in this data set. Similarly, they come from 3 different islands, and then we have 2 sex levels, male and female, that are recognized here. And I also want to point out that ours can recognize both when your factor is written as a character. So here we see the name of the penguin, we see the name of the island. But if you look here, it can also recognize your factor as a number. And so it's really important for, again, when you read in your data set, when you're looking at it, that R recognizes the variable as you intend it to be. And so if you have, for example, say you do things with time and you just use time 1, time 2, not pre-post, when you read it in, R might take 1 and 2 to be numerical integer. And so it's important that you transform that variable, if it is a factor, into a factor, so it doesn't read 1 and 2 as an actual number, but rather this special factor variable. Okay. And so I wanted to open up with factors because the first thing that I kind of want to do is, okay, I'm interested in visualizing the species information in some way. And if, say, this wasn't a factor, so for demonstration's sake, I am going to change this into a character, meaning R is just going to recognize this as a word, like character word. And I wanted to plot the counts. So like how many, species of Adelie do I have? How many species of Gintu? I actually don't know if I'm pronouncing that right. Do I have, if I wanted to plot that, and for this, I would use a bar plot. Running this code is going to give me an error because this is not something that can be plotted, at least not for the purposes that I want. And so having this as a character is not going to produce the plot that I want. And to emphasize this further, because we can count, again, when we have categories, we can count these things. And so if I have species recognized as a character, I think this should still work, but it'll give me, so here, this function is sort of transforming species into a factor for me. So it's just putting each time it sees like Adelie into a bin and it counts it up. So we don't actually need this because in our original data set, species is already a factor. And so this is just a quick way for, any time of descriptives that you might need, this is how many species I have. And so again, to sort of start with this, we're going into bar plots. I know that traditionally bar plots in psych especially are used to communicate statistical information. So we might use it to plot means. We throw error bars in there and be like, oh, look at the difference between, these variables. But in a true sort of data science focused, data visualization focused way, bar plots are typically used to visualize counts. And so it's when you have a category and you just want to show this is the amount of X, this is the amount of Y that I want to display, because you start off at 0 and then, you go up into however many. And so this is how I use bar plots, and this is how I'm going to show how to create a bar plot. And I am, still going to show how you can use it to display a statistical information. But I would just say that for, advancing forward, being interested in this type of thing, that to sort of move away from using bar plots, again, to sort of communicate trends or statistical information. And so to sort of cap, I want to create a bar plot. And again, all I want to do is display this information. So how many of each species are present in this data set visually. And so we can create bar plots in 2 ways. First way is we have this, what I call a manual transformation. And so when I run this, you'll see that I don't actually retain my original data set. This is my data set. But by running this count function, it tabulates, if you will, a new data set for me. And so when I go to plot, these are my columns. If we go back to understanding where our data is in this ggplot fundamental data aesthetics geometries. And so if I want to plot or create my bar plot, one way is to use the function genome call. And the reason that we use this is because, again, we have transformed our data set into this tabular form. And so as you'll see in my parent call, my X is species and my Y is N. And then I like to use theme black and white. And so I'll just use that for all my themes. And when I run this code, I get my bar plot. And so you see it has the name of my species. So it, again, because it recognizes as a factors with 3 levels, and it has the counts of each species. If I wanted to actually plot something from here, so say I wanted island to show, the count of, okay, here is how many islands or the levels of islands that I have. This is not going to work. And the reason why it doesn't work is because our data, or our tabular form does not contain this column. Like island is not something that exists in this step that we have right here. So, to further iterate the point, again, for the people who weren't here, for the first visualization, it really is important to understand where your data is coming from and what's being read into the ggplot function, in order to produce the plot that you want. And so this is why we have this, and it works. And if I didn't want to count island, all I would have to do is change this. So if I did island, oh, mistake. Island, I have 3 different type of islands. Here are the counts, and all I would have to do is change this, and I produce another bar plot. And so that's one way to do it. And again, this is using the function geom call. We can also change this to plot specifically the things that we're interested in. And so if I wanted to, and again, notice how I'm constantly doing this manual calculation to get my table of how many species that I have. And say that I was just interested in just 2 species. I didn't want to see all 3. I can filter this to just include this Gintu and Adelie. And then I pipe this into my ggplot. Similar as above, where again, I'm mapping my parent call aesthetics to X and Y, plus sign, using this geom call, and then adding my theme. And there you go. Now I only see the species that I'm interested in. And so if you're someone that, maybe again, you have something, it has a lot of categories, but you're interested in only visualizing a couple of them, you could use this filter function right here to do this. And geom call is just a function that creates columns. So this is, or bar graph columns are essentially the same thing here. And as you'll see, Y, because I manually calculated Y, that's why I set it to N, which is our count. And then you have our X-axis, which is the species. However, we can also create a bar plot using geom bar. And the main difference between geom call and geom bar is that within your geom bar function, when you do a manual calculation, so what I mean by this is, again, let's count how many species that we have. So when we have something like this and we use geom bar, and this is actually a mistake, you'll see that we'll get an error. And we have this error because R doesn't understand how to create a bar plot when we have an X and Y aesthetic in our parent call. or at least when we have our X and Y aesthetic and we just say geom bar. So to actually produce the same plot that we have above, we need to include this stat includes identity call within geom bar to produce our bar plot. And there's really no difference between, well, I should say our first bar plot, or our first geom call. I'll change this to species again. So this plot and this plot are functionally the same. You'll see even the y-axis is the same, because even though we had an error previously, by including stat equals identity, now R understands that, okay, you're providing me an X and Y aesthetic, and I need this behind the scene to tabulate or create this plot for you. And you'll see that, or the main difference between geom-call and geom-bar is we can actually plot, again, if you correctly set this variable to be a factor, we can just jump straight into geom-bar. And so here it works. And again, these are functionally the same plot. The only difference here is R calculated this for us. You'll see the y-axis is count, and this is what we did, but manually in the step before. And so these are, again, the same thing. The only difference here is that here we already recognize that species within our original data set, this is a factor. And so if we want to create a bar plot, geom bar, you include a theme that you like and it'll do it for you. Similar to before when I was trying to do island, but I got that error because it didn't tabulate when I used count before. Easy peasy. You just straight jump into it, and you have your plot. Any questions about this so far? All right. Feel free to, put it in the chat if you want to talk. But to kind of illustrate the difference between these further, so geom bar and geom call is, so I mentioned before that typically bar plots, you use it for counts. So in the same way that I use it here, it's just to visualize, very quickly, this is the most common island in this data set, or if we're going back to species, Elie seems to be the species that's most present in this data set, and chinstrap is the one that's least present. But if you wanted to use a bar plot to visualize some kind of statistical or descriptive summary, this is where understanding the difference between being able to use geom bar, geom call comes in. And so here I want to do kind of quickly summarize all the values in this data set that are numeric. And I'm using numeric because, again, traditionally, this is what we use bar plots for, even though, again, typically, I want to say they're reserved for categorical variables, or here are factor. And so this just creates, again, another little tabular new data set that just calculates the average of all my other columns that are numeric per species. So for the Elie species, the average bill length for this type of penguin is 38 millimeters. Same for depth, flipper, and then we have bill, body mass in year. And the reason why, if you're curious, we reserve the species column is because this is my grouping factor. If I didn't have this, I would just have just the columns that are numeric. And so, in your own sort of statistic flow, process flow, you might create a table like this. And again, especially with means and averages, you just want to visualize this in a bar plot. Here, I'm going to pivot everything just for demonstration purposes, except for my species variable. And all that does, it creates a sort of another mini data set where now I have all my numerical variables, and then I have the mean for each. And so if I wanted to just plot these, I need to have my aesthetics within the parent call match the name that I see in my data set. And so if I do this, geom bar, again, see, I don't need to use stat identity or anything like that. Well, actually, this will cause an error. I'm sorry, I misspoke. So yeah, whenever we have an X and Y aesthetic and we have to use geom bar, we're not going to be able to plot what we want if we just leave it like this. We need to have this stat equals identity function in order to produce what we want. And what I actually want to plot are just the values that are measured in the same units. And so I want to filter out body mass because this is measured in grams, and then I want to filter out year because that's just a year. And so what this is going to do is it's going to give me a bar plot, and it is just going to show me the value of all the numerical columns or variables that I have that are measured in the same metric, so millimeters. And this just shows the mean. So across all the species in my data set, across all the things present, these are the mean of the build depth, build length, and flipper length. And so, yeah, the reason why I kind of wanted to demonstrate this different way of creating a bar plot, because you could start with, a very tidy data set where you don't have to do a lot of data manipulation, data tidying, and you just want to create your bar plot easy peasy. But if there are some transformations that you have to do, some computations that you have to make before you create your bar plot, you are going to need this XY or stat function. And if you ever forget, this could also be created using geom call. And again, the only difference is you can run this without the stat identity, and it creates the same exact plot. Had a question in what the pipe means. So in the tidyverse kind of package, this is just a way to carry one object into the next thing that you want. So starting with my data set, I want to pull the species variable, group everything, then I'm piping it into the summarize function that creates my mean for me. And here we want to have NA remove equals true, because if we remember before, we do have some missing values. And if we didn't have that, we wouldn't be able to compute our mean. And if you've ever had this happen to you, this is what that means. So you'll see that I have no value if I don't drop the NAs, but if I remove them, I'm able to retain what I'm looking for. And this is just a way to filter things. So I want within this new column I created for name in body mass year, because of this exclamation mark, this is why it's not included. But this is just a way to filter things. Again, this is for the purpose where if you're working with a large data set, you're working with many categories, but you're only interested in visualizing a couple, this is a handy dandy way of doing that in like a very streamlined way without having to do too much to your original data set. Okay, so now that we've kind of covered, okay, this is different ways that we can create bar plots, I'm going to stick to just using geom bar, especially when we have, when you have your factor and you have your categories, and say you wanted to kind of display it in a way that's like, okay, I want to go by order. So here, we can arrange our species count. And so this is going in ascending order. If we wanted to go in descending order, we just include this and then it'll start with the biggest category above. And if we wanted to plot this or plot our bar graph so that it reflects, say, the largest species to the smallest, we could do that. And the way that we do that is by using, did not mean to do that. The way that we can do that is by using helper functions. And so here are helper packages. I'm going to be using a package called forcats. And this package is really, it's really helpful in using, in manipulating factor variable types specifically. And so if you don't have the package, you will need to install it. And this is the name. So forcat s. And for me, sometimes if I use a package not that much, I don't like to run the full library. And so if if this is not something that you're familiar with, a way that you can still call functions from a package without loading it is by using these double semicolon. And so you write what the package name is, here forcats, and here I want to pull this function, factor and frequent, and this just means that I want my factors to be arranged in frequency order. And so this is just going to order my factors in this manner, because R by default, when you have factors, it just organizes them in ABC order. And so just by whatever the name is, our first factor here, it would have been Elie, this is our second factor, and this is our third factor. And again, by default, R just likes to organize them by ABC order. But sometimes just because our factors are in ABC order, that doesn't mean that's the order that they're in. And so this kind of rearranges our factors so that when we plot it, it'll plot it in descending order. And so here I am again, just using geom_bar. And I want to make a note that this step, like using forcats to arrange my factor in descending order, it's not a statistical transformation. So I can create a bar plot without having the stat equals identity function in this call, because I'm not doing any sort of like statistical or manual count of anything. I just want to arrange my factor in a specific order. And so using this function, again, we have our new plot. It's conveying the same information, but now it's just more clear which species has the most count and which one has the least. And you can do this also in the reverse order. If you wanted to go from least to greatest, again, we sort of start with this in species or in frequency mutation. And then we use forcats again, and this is this factor reverse. It just means, okay, you've organized your species from greatest to least. Now I just want to reverse the order, and so it'll go from least to greatest. And again, the reason why we have to do this is because by default, R likes to organize things in ABC order. So if we didn't have this and we just had the reverse order, it wouldn't put it in how numerically, it would just start with Ginto, then go to Chenstrab, and then end with Elie, because that's the reverse of the default, if that makes sense. And then it's the same call that we had before, where we have, again, our simple geom plot call. And another thing that differentiates when you have to use identity versus not is here we only have one aesthetic within our parent call. We don't need a Y aesthetic. We don't need to supply it because R kind of just does that for us. It just manually behind the scenes count the number of species we have. And here we have it in the reverse order that we had before. But again, compared to something like this, where our Y value is something that specifically that we want. Here, this is reflecting the mean. This is why we have to do this stat equals identity because we want something different here. Because again, by default, geom bar is just going to give you the count because just typically that is what a bar plot is used for. Okay, and then the last thing I want to say about bar plots before we kind of move on is that you can use this to show proportions, especially, this is important if you have sample sizes that are not balanced, and so it might be more honest and true to what your data is communicating to show the proportion of your count versus just the raw count or sum. And so here, the way that we want to do this, and again, this goes back to the important or why I wanted to open with the different ways that you can create bar plots is because in real world wheel setting, it might not be as straightforward as just creating a bar plot. Here we want to sort of create the things that we're interested in. And so I just started with the thing we started from the beginning, which is counting my species and then calculating the proportion. And all I have to do is take this value, so n, and then divided by the sum of all the species. And so that's why we have this sum n here. And because we have, again, this is a statistical transformation or computation, right? Like we are changing the numbers. When we go on to plot our bar plot, we are going to need this stats identity function. And again, a quick way to gauge that is because we want to set our y-axis or the y part of our chart to this specific value to reflect the proportion. And so geom bar stat equals identity in quotes, and then theme black and white. And there we go. And you'll see visually, it looks the same as the bar plot that we created before that shows the count. But this is just a way, again, of showing different pieces of information, especially if the sample size that you're working with kind of calls for you to do some type of statistical transformation to display your bar plot rather than using just a raw count. And similarly, this also works with just geom call. So if I ran this, I have the same plot. I just commented out this function. And so you'll create the same thing. And this is how you create your proportion. Okay, any questions about bar plots before we move to histograms? Okay, so histograms typically are used to look at continuous distributions. I should say, well, you could use many things to look at distributions, but for continuous specifically, default, what I like to use are histograms. And so for this purpose, we'll just pick a continuous variable from our data set, and this is just something that's numerical. And so to do that, I want to look at bill length to see what the distribution is. And the reason why I have this drop NA is first, I want to do some quick summary statistics of this variable. And because I do have some missing value in my data, if I didn't have this drop NA, it wouldn't show me anything. Everything will be NA. And so to actually get a value, I need to include that there. And so I have this. And this is, again, just a quick way to look at your basic descriptive, so mean, standard deviation, max min. And behind the scenes, so this part, okay, somebody asked if there's a generic key to create the pipe. If I'm understanding correctly, so I'm working on a Mac, and the way that I kind of like my shortcut is Option, Command, and I to create the pipe, the tidy pipe. No, actually, oh no. But I don't know how this works in Windows. But I'm sure there's a way to Google it, maybe. Oh no, I keep doing the wrong thing. Okay, so yeah, what I wanted to show really quickly was behind the scenes, a histogram kind of works functionally a bit the same as a bar graph. And so this is not like, this is a bit more, oh, I misspoke. To create the pipe, it's actually Shift, Command, and M. But anyway, so to kind of show again behind the scene what's happening when you create a histogram, it kind of works again, this you can manually build it. There's no reason why I think you would do this unless like your variables is something very special. But here I'm just creating different cuts of my continuous variable. So this is just saying take bill length, and I want you to break it so that, you know, it starts with whatever the smallest value of bill length is. And then you go up to whatever the biggest value of it is. Like we don't want to include values that do not exist in our data set. And then I want you to make like about 6 bins, if you will. So if I were to run this, this will actually be all the way at the end. But here we have this new variable where, again, it kind of starts, well, this is just saying which bin this particular value of bill length is in, but it'll create 6 bins for me. So like 6 kind of groups, or you can call it, you can kind of think of it as 6 factor levels for me. And I can use this or this transformation to go and plot this. And you'll see I'm using geombar. I have to do a bit of transformation here where I want the y-axis to sort of reflect a proportion of bin that exists, but I don't want to completely do away with my original data set. So that's why I'm not manually creating a proportion variable like I did up here. But, and again, this is just to demonstrate kind of behind the scene what's happening. Is so this looks, again, a lot like a bar plot, right? Like we were using before. But if I change the how many bins that I want to produce, so from 6 to 34, now we can see that this is starting to look a bit like a histogram, right? Because the more bins I have, and again, this is what is happening when you plot a histogram. It's showing within this bin, so within this value of bill length, although it's not legible at all, here is the proportion of, you know, participants or penguins that have this bill length. So at the lower end, we have a really small proportion of penguins that have this bill length or within this bin. But within the middle, right, like particularly here, again, I wish I could read what this said, but This is again just showing within this, small interval of bill length, say this is 30 to 40, we have about this many, or this is the proportion of penguins within our data set that contain this bill length or have this bill length within this interval. And so all of this kind of long way to show that when you go to plot a histogram, behind the scene, this is what R is doing. It is just taking your continuous variable, that R recognizes as that, and it's just behind the scene doing the statistical transformation where it's binning things into different values, and it's showing, okay, here is again proportionally the distribution of your data. And so when I run this, you can see that the outline that we have for this histogram is very similar to this bar plot that we created to kind of show what's happening behind the scene. So that's to say, you do not need to make this to create a histogram. Again, this might be if you have a very sort of weird variable that you're working with where it's not necessarily continuous, and so R wouldn't be able to read it that way. And maybe you need to make like these arbitrary cuts. But creating a histogram, it's really pretty straightforward. All you need is for a parent call or X aesthetic, and then you have geom histogram, and you'll see that similar to our default bar plot, our Y is the count. And that's why we have that here. And so that's, again, a lot of lead up to something that's very simple, but I just wanted to kind of go over it to kind of, again, show when it comes to visualizing, this is what's kind of happening behind the scene. And so for histograms, this is where, like we'll get into this, how to manually color things, but this is where we understand the difference between fill and color. And so if we want to change, because you might say, oh, I don't want my bars to be gray, I want to change the color of your histogram. You wouldn't actually use color to change it. You would actually use fill, and it'll create whatever color you want. You can use color, but all this does is it colors the lines. And so in R, whenever you're plotting things similar to this, if you have a 3D space or something that you can kind of color in, you use fill to change the color. And then for things that are like more lines and including scatter plots, so if you had you wanted to change the color of your points, that's when you use color. And then the last thing I want to say about histograms is that you, by default, so ignore this warning, but if you see this warning, R likes to use a bin of 30, similar to, again, the breaks that we were creating here, the bins that we had here, right? So like if I change this to 30, this will be more similar to what we see here. So again, the purpose of that was just to show what's happening behind the scene. If you're okay with that, like, bins of 30 makes a histogram that is reflective of what you have in your data, it'll do away with the warning. And this typically works if you have, a sample size that's pretty normal. It's like you have enough of things, but sometimes if it's too small, a bin of 30 might just be, it might make your plot look weird. So this is just a way of showing how to adjust that. So if you want less bins, so less bars, you can decrease this number. You can make it 4. Again, this is very hard to read. But if you wanted to include more, you could increase the number. And there's a bit of a gray area in terms of where do you stop? How small do you make it? How large do you make it? And I think my rule of thumb is, again, I kind of stick to the default. I'm like, okay, this is pretty honest. Like it's relatively normal, but we can see like there's a bulk in here. Like I would be okay with using this to communicate the distribution of my data and feel okay with it. Something like this, I would not use, right? Like this is just now we're clumping too many things together and we're losing sort of like the information that's valuable for that. But that's just like a way that you can use this to sort of change, again, how many bars your histogram has. Okay, and I'm just going to use the same plot. So here, although we have, we're showing the distribution of this continuous variable, we can also use it to kind of show, okay, what's the distribution, but by the number of species that we have. And again, sort of calling back to our aesthetic conversation, the way that we can show additional variables in our plot without changing our parent call is by using an aesthetic function within our geom. And I'm going to include my comma. And so here I want the fill, or, instead of being pink, I want it to be species. And you'll see the difference here is for things like pink, black, I have to put it in quotes because I'm manually coding or manually changing these. But this is telling R, like the species column that you see in this data set, in this data set, I want you to color the bars or fill in the bars of my histogram by this variable. And so when we have that, we see that, okay, we produce this legend, and this is always going to happen when you use an aesthetic and you use it as a way to display a variable from your data set. R populates this legend for you to tell you that, okay, this mass of blue here is the bill length distribution of Gento. This red is Adelie. But this, and you can use like color again in the same way that you can use fill. And again, for things like histograms, bar plots, or even box plots, color is not going to color in. This just refers to the lines. And so we can also make this kind of like the same color, although it'll be hard just for the purposes of seeing what this does. And you can change the line width. And so I don't know about you, but if you've ever tried to change the actual color of your histogram and you get this, this is probably why it's not changing, because the colors control the line, which is kind of like not really intuitive. But it just makes it clear, like, okay, this is my cluster of this species, this is that species. We can see that there's some overlap between Adelie and Ginstrap. But overall, this is not something that really communicates anything effectively. It's actually kind of hard to look at. Another way that people can change histograms is by creating a dodge histogram. So this is going to separate, instead of seeing this overlap of lines, we can separate them out. And the way that you do this is with this function, position, dodge, and you'll see that this is not within my aesthetic call. Anything that doesn't refer to using another variable in your data set to do something in your plot, you do outside of this aesthetic call. And so, yeah, controlling the line, controlling the position, controlling the bin, this is all just hard-coded. And again, this is not really a functional plot, but all it did was stack or place the bins side by side next to each other. So instead of having this overlap, we can see that it just spread out our plot a bit, excuse me, to have things side by side. Any questions of that so far? We can also, again, this is not a histogram that really conveys anything, but if you find yourself needing to know how to sort of do these different functionalities, this is a way to do it. We can also fill in or color our plot in a way where instead of having all the bars for each species stacked next to each other, we can just have the color within one bar kind of reflect what each species is. And so to do that, oh, you can't do that. You could do that with a bar, again, sort of, if you were interested, no, actually, you can't do that. But this is kind of just showing typically histogram, this is where you would end things. Sometimes maybe you might want to add like a density curve to your histogram. And to do that, it's just a geom called geom density. And this actually also needs a stat. Oh, no. Yeah. You might need a geom density line, but I'm not understanding what's missing exactly. Huh? But okay. Maybe if I change color equals blue. Okay, there we go. Oh, okay, I see. So this gets a bit complicated, but even I need a refresher on this. To overlay or to overlap your density line with your histogram, you do need a stats equals identity, but I put it in the wrong layer. So it actually goes in your geom histogram layer, y after stat density. There you go. Again, if this is something that you ever wanted to visualize or find yourself visualizing, this is terrible. This is a way to do it. But just for the purposes of creating a simple histogram, it's pretty straightforward. And the only thing that really might give you pause is the number of bins that you use. Any questions on this part before we get into the more complicated thing of box plots? Okay, so the reason why, like, although these graphics are fine in a way, again, they don't really do a good job if your purpose is to communicate distributions, especially if you want to condition it on another variable. Again, it's kind of hard to see what's happening within each species, even if the colors weren't like this. Fill equals species, and maybe I want to change the transparency of things to see if there's any overlap. Like this is still not, again, anything that it might be fine, right? Like you again kind of see where, okay, within this, overall this distribution here are where each species are clustering in. But to really look at distributions that are conditional in a more effective way, I would recommend to use box plots because then it's easier to see how things are conditionally distributed, and the relationship between that continuous variable and the categorical or factor variable that you want to condition your distribution by. And it makes it, again, easier to interpret things when you have them side by side, rather than staring at this for a really long time, trying to understand, okay, what's happening here. You can use a box plot as a way to more effectively visualize your distributions, especially because box plots have quartiles or quantiles. So they'll show you your 25th, 50th, and 75th quantile. And the way to do this is, again, for ggplot, you always want to start with your data, then you want to start with your parent call. And for box plots, you do need a y and a x and y parent call. Because in our x-axis, as you'll see, we're going to have our categories, if you've ever seen a box plot. And then on our y-axis, we're going to have the value of our continuous variable. And so unlike the geom bar and the histograms, you don't really need any stat density, after stat, anything within the box plot. You just need the variables that you're plotting. And so again, we have our species, and again, by default, R is going to order these in ABC order, and then we have our Y variable. And so this is just, again, showing a distribution, although it's not, again, used very widely within psych and specifically. This is just a more, again, data-focused, data-driven way to show our distributions for when we want to see the relationship between a categorical and a continuous variable. And this is, again, pretty simple as our base plot. If we wanted to customize this in a way where we want, to fill in our box plot or color it to reflect our different species, it's the same where we're going to use the aesthetic call. And here you can use fill in color the same way that you use fill in color for a histogram or a bar plot, where fill is going to color in the white spaces within the box. And so I'll just do that first to show what that looks like. And then color is just going to change the color of the black lines around the box. There's no real rhyme or reason to do both fill and color. I think it kind of just falls down to an aesthetic thing mostly. But if you kind of just want a straightforward way of showing this, you'll see that it populates a legend for us as always. And here we can easily tell what the difference between the species are. So in a way, the legend is a bit redundant because our x-axis also communicate the same information, but that's how we have it. If you wanted to sort of inlay, so here we just have quantiles. We actually don't if we wanted to see the average, we could have that. And first, I'm going to show how you can plot this really quickly. So it's going to be the same parent call as our box plot, where we have what we want on our x-axis, what we want on our y-axis, and then we have the stat summary function. And so this is just saying, okay, I want to, calculate a statistical summary, descriptive, and here I want it to be mean plus some standard deviation. And so what we're going to get is just 3 simple dots that shows the mean build length of these 3 species. And then we have our little bar to show standard deviation. This is showing 1 standard deviation by default, but if you wanted to include more, I like to use 2 just to be safe. You just include this additional argument where you list out, you see that it stretches the bar a little bit. But again, this alone is not really meaningful. This could just be in a table if your purpose is just to show here are the different means. And so to actually have it be a more meaningful visualization that conveys more information, we're going to add or combine the box plot along with this stat summary function. And again, the way that you do that is you start with your parent call. And this is why I don't think I talked about this explicitly, but in other codes in the wild, sometimes you'll see people put a lot in the ggplot call itself. So here they might have color, they might have fill. And the reason why I stray away from doing that, and I would recommend that you stray away from doing that as well, is because it's easy to see exactly what the base of your plot is, especially if you get to a point of building more and more complex plot where you're adding a lot of layers. It can get very long. It is kind of confusing, especially for reproducibility purposes, to see, okay, you have this color here, but what layer is it in, right? Like, where is it coming from? And so keeping your parent call very simple, very clean, like this is the basics of my plot, it becomes easier, again, to sort of keep track of what's happening in your graphic and where things are when you go to make changes. And so here I'm creating my box plot, but I want the color to reflect the different species. I might change, well, I'm jumping ahead. So let's just do that. Change the species, and then we're going to add, and the way that the layering for ggplot works is this is going to be on the bottom layer, so box plot, and then I'm going to add, box plot, and then there's going to be a stat summary at the bottom. And so I'm just taking the same code that I had up here, and I'm just combining it with my box plot, and you just do that with the plus sign. And so, yes, I want mean, standard deviation, I want up to 2. And I also want, because you can use mapping for everything, instead of just being black dots, I want the colors. So it's weird. For dots, you use color to actually change the color of the dots. I want it to be the color of, again, to match the color of my species. And then last, this is just the theme that I like to use, black and white. And so now, again, the way that it works, you have box plot, you have stat summary, but it's really hard to see where my stat summary is because it's the same color. And so this is what I was jumping ahead before, where I can turn down or make my boxes more transparent. And then it becomes clear where my average lies for my box plots. Someone asked if you need this mapping here. You don't. You can just do AES, like I have it right here as well, just for demonstration purposes, right? Like when I want to use an additional variable from my data set, I think it's nice to see, okay, I'm not choosing these colors, like I'm not making this red, green, black. I'm just mapping this variable to be, to reflect these values, and R just kind of used their standard color palette for me. But again, if this is like, not legible, you want to say something more about the color specifically, we can always hard code or manually code this. So I'm taking away the mapping aesthetic function, and I just want this to be a really bright red. And then we get a really bright red. And then if you wanted to change anything else about this, and then you'll see even again, our legend changed. And so if I go back when it was mapping, our legend really neatly reflects the stat summary function in it. But when I hard code it, you'll just see that it reverts back to a simple box plot. And so you have this. Okay, so that is my coverage of, again, sort of the most commonly used, I would say, plots. Aside from a scatter plot, we can make a scatter plot. But since we covered that in the first one, I wanted to show more complex plot, but say we wanted x equals bill length and y equals bill. Yeah, the only difference between these is that for a scatter plot, both of your parent call aesthetics are continuous variables. And so this creates our scatter plot. And again, if we wanted to add an additional variable in there, we wanted to see, like, is there some, like, yes, there is this relationship between bill and dep, but does it vary by species? The way that we can do this is by mapping our color aesthetic to species. And then it'll change the plot for us. And we can, again, when you get into like this rhythm of exploring your data using visualization, you'll see that a lot of the plots complement each other. So because we had, although this wasn't really helpful, but because we looked at it anyway in our histogram, seeing this is not really surprising, right? Like, because our histogram did show that within our distribution of just bill length, there was different clusters of where each species appeared. It wasn't an equal distribution across all our species. And so even by adding this additional variable of like a second continuous variable, it's not surprising that, okay, we have clusters of, Elie, this is where they tend to range. The middle one is chin strap, and then we have Gentoo kind of at the bottom. And so I would say like there's never like I kind of tend to exhaust all the plots that I can that are at my disposal when I get to exploring data, just because you can kind of glimpse a lot even before you run a model. And sometimes when you do run your model, it's like, okay, I'm not surprised by my results because of my visualizations. And so, for example, here, like this is box plots, or what I like to use to show like any kind of statistical difference. By looking at this again, no model ran, you might expect that there would be a statistical difference in bill length between Gentoo and these two species, because the distributions are clearly very different. But between Elie and Stinstrap, it might be surprising to see that there is a significant difference because they kind of have a similar distribution, right? Their mean is hanging around the same, quantile hanging around the same. Really, these two are more different compared to this last one than to each other. And so when you do go run your model, you can just go back to this figure as like the result. Maybe the thing that you add are a couple stars to indicate what's different, but it's kind of like two birds in one stone, where you don't have to create an additional visualization to reflect your the results from your statistical model. And I hope that made sense. And so, yeah, so those are the basic kind of big three things that you can use to sort of start your basic data exploration. Bar graph and histograms are a way to kind of look at a singular, or they're best used for looking at variables in isolation, where you just kind of want to understand the basic counts. If you have a categorical or a factor level, like this is how many female versus male, this is how many, species that I have. And then for things that are continuous, you use your histogram to kind of look at the distribution. Do you want it to be normal? Is it skewed? And so that's helpful there. And then a box plot is where you get a bit more complex, where you can start looking at relationships. And the number of relationships that you include is really up to you. Kept it simple by just looking at two things, but sometimes box plots, you can make them very complex and start adding layers on top of each other. Okay. And the last thing that I kind of want to cover is, so I kind of mentioned before, right? Like these colors, I didn't pick them. They're just the default. are colors, but if you want to, not if, I'm sure there are many people who are like they want their own color. So this is creating like a custom scale. And in R, you can change something in your global functions where it'll highlight the hex code into the color that you want. If I also want it to be blue, that's why I have that. But you can use hex codes, and I'm just creating an object to store all of this. And I want to create my box plot again, but this time I want to have my own color palette. And so the key thing to understand when it comes to customizing your plot in this way is that we're using this scale function here. And there are two. There are scale, at least for color purposes, because there's actually a lot. We have scale color, and then we have scale fill. And they work in the same way that regular color and fill do, but to use them, your color and fill have to be mapped onto an aesthetic. And so I can't have like here color equals pink, color equals whatever, because I want to use my own custom scale. And so when I run this, now we see we can actually, we don't need to color those dots. Okay, now we see that my colors reflect this palette in the order that I stored the colors. And again, by default, R is going to do this in alphabetical order. So if for some reason you wanted purple to be associated with the first species, orange with the second, all you have to do is change the order here. You run it, and then you see that it changes the order of my plot. And so all you need is this function, scale, fill, and manual means pretty straightforward. Like you're manually setting the colors. Name is what I want to name my legend or the color of this legend. And then the values is the actual, like, what do you want me to color or fill in? For this variable, it refers to this custom color palette that I made. Another way that you could do this is if you have just simple colors that you want to use, instead of pal, you can just do this and it'll create the same plot. It's just another way of changing that. And here, this will just, if you're going to use a name, a special thing is, so I wanted to change it here. You'll see that instead of being lowercase, I have an uppercase species. If you wanted to customize your legend in that way, if you don't, it'll just auto populate whatever fill or whatever you map your aesthetic onto. And so without that, it just creates the species the same way that it's named in my data set. And the same thing for color. So if we had something that we wanted to color, this is not a good example because we don't actually have much to color, but it's the same where you have scale, color, manual, and you want to keep these things consistent. So if okay, I'll show a demonstration for why you want them to be the same, like if you're naming them. Because now it'll create two legends. It won't work because color has to be something that's continuous. Or let me retract. The reason why I'm having this error is, again, to use scale functions, you have to have whatever the thing that you're changing as an aesthetic. So because I didn't have color as an aesthetic within my box plot layer, this is like, okay, you want me to change the color, but you didn't even actually have something to color in your plot. So that's my fault. Oh, but if we want to change this, come on. Oh, and we have this mistake. Okay. Now the difference is that, again, it's hard to see color with box plots because it just colors the line. If I wanted to make it more apparent, this is what's happening. And you'll see that it gave me um, an extra legend. And now this legend reflects this. And so this is why you want to have things be consistent. If you're wanting to manually change things or you have to manually change something, the way you spell things, the way that they're laid out has to be the same. And now we have one consistent legend across our plots. Okay. And then this is just a way where if you want to, again, kind of going back to changing things, like say you wanted to reorder things about your legend, you wanted to move things up and down, you can use, and this is getting into themes and moving away from color a little bit, but we can use forecats again, the same helper package that we use to create our bar plots in ascending and descending order. We can also use it here for our box plot, but this is, again, not going to change like the information of our box plot by any means. It's just going to change the order. And so the way that we do this is, again, we're going to use this mapping function, but instead of just saying mapping to species, we're going to use our forecast option again, and use this order infrequent. And then we want it to be species. And if we wanted to change the color, we have to do the same exact thing so that the color around the box plot matches the same exact fill as the box plot itself. After that, I'm just going to change the alpha or the transparency, decrease the size so that we don't have these big harsh lines, and then scale fill. Manual values equals pal. And I want to show here, so whenever you change or you do some kind of transformation within your aesthetic layer, it is going to reflect within your legend, because whenever we use something from our data set to map it onto something in our plot, it is going to create this legend for us. So because we did this, transformation here, it changes the name of, it changes the name of our legend to whatever the function is here. So the really easy way to do this. So the first way that we saw is you can change the name of your scale here, but we can also use labs. And this is a way to also color or label your X and Y axes, label your plots, but we can also use it to label our legend, especially again, if we're doing some kind of transformation within our aesthetic call. And so by doing this, now we have a legend that shows just species instead of forecats infrequent, because people don't need to know what's happening behind the scene. Someone did leave a helpful comment about other kind of colors that you can use, especially things that are more friendly for everyone. So this is just a way to show like if you again are working with a custom scale, say you're working with a company and they have their own color palettes or whatever that they want to use for their visualizations, this is a way that you can create that with R. But if you wanted to again, you don't really care about the color, but you wanted to make it like say colorblind friendly, you can use Other helper functions, so something that I like to use is GG themes. And if you don't have this, again, you'll have to install it install the package, and you can call it this way. But if I do scale, fill, there is a colorblind option. The key thing is that you want to make sure that whatever comes after scale is matching what you have, like the thing that you're changing, right? So if this was color, this would also need to be color in order to be effective. But if we run this, now we have a colorblind friendly scale that R provides for us. It just picks whatever the first three colors are, because we only have 3 levels of our factor. If we had more, it would include more colors. And so this is a way that you can do that. And there's plenty of other scale functions as well. And so again, this is just a drop down menu, and the variable type also comes in order. So if I wanted to, so this is Veritas, it is also another color palette, and this C stands for continuous. And I don't think this is going to work because our the variable that we're coloring by is not a continuous variable, it's a factor. And then so it could be considered discrete. And so if I wanted to use that, use D, and now we have a different set of colors. Again, it just kind of pulls whatever the first 3 colors are, because we have 3 factors, and that's a way to change it. Again, if you don't want to go out and hunt for your own custom color palette, you kind of just want to see the other options that are available in R, this is a way to do it. If you wanted to, so that's changing color palettes, but kind of like mentioned before, our x-axis kind of reflects exactly what's happening with the legend. So here our legend is not really necessary. And so if you wanted to get rid of your legend, one way to do it is, again, going back to our labs layer, and we're just changing the color. We actually don't need color because we don't have anything. We don't have a color aesthetic that we need. You can just change it to null. And it'll take away the name of the legend. Again, this is kind of being reflected here. To do away completely with the legend itself, we use guide, which is something that comes from themes here. But this is just an easier way to access it. So as a guide, you can think of the legend as a guide. We say fill because that's what we have that's being mapped. And then if we say none, we have a new plot. We got rid of the legend because again, it is sort of repeating information. If you had a color, like, so if your legend was a color, you'll see that it's going to reappear, even though you have this none here, because we actually don't have a fill anymore. And so if you wanted this gone, we'd have to change the name to match, and then you got rid of your legend. So that's that. I do want to kind of show kind of making the plot a bit more cleaned out. So I want to give it a title. Point species. I want to maybe capitalize species on my x-axis, and I want to change my y-axis in milliliters. Actually, I still don't need my legend. If I do this, now we have, a plot that is more conveying of what's happening there. We have our title, we have capitalized things in our X and Y axis. If I wanted to move my title, this is kind of touch a little bit on on the first one, but for theme, like specifically, like no underscore, but theme is the go-to for really getting into the nitty-gritty of customizing your plot. So for some people, like they completely change everything, and the way that they do that is by using this. I hardly ever use it to that extent, but for things like moving your legend title or your plot title, maybe you want it to be in the center. The way that you do it, you call plot title. For anything that has to do with text, you're gonna need this element text function in front of it. And this H just is just our horizontal justification. 0.5 is like center. I think it's like 0 to 1. And now we have it in the middle. If we wanted to do something with, so let's put our legend back. If we wanted to change our legend, we would also go to this theme, no underscore, to do that. And for things like it'll say legend, and we see we have all this option. And the only thing that we want to do is change the legend position. And maybe we want it on the bottom. Maybe we don't want it on the side. And there you go, you have it on the side. And maybe we also want the legend to have also a capital species. And there you go. You could even put semicolon since it's on the side, and it'll change that for you. And so those are kind of like, again, not exhaustive set of how to change things by any mean, but it's definitely like the basic that you need to kind of move forward. I remember like in my first year of grad school, I had a histogram where I wanted to change the colors to match my control and treatment, and I had no idea how to make the color change, how to have my legend reflect treatment and control, like Googling so many things for, what to change. And really all it came down to, like, I had to understand, okay, for my scale, I had to, do it a fill to actually change inside the histogram. And within this, you can, also do functionalities of setting the name, setting up your values. But this is again sort of like the basic entry. I think when you kind of like riding a bike, right? Like once you get your training wheels off, you can consider this. It's easier to then go into more advanced, like things that are further advanced. And when you do see code out in the wild, it's easy to understand what's happening within each layer of your plot, and what's actually being changed versus kind of being confused, and maybe you're relying on recycling code without really ever understanding, like, okay, what's happening actually with my code. But yeah, so if I'm gonna pause here for a bit to see if there are questions. I think I kind of covered a lot, and we are nearing up on time. The last thing that I kind of wanted to cover was quickly is showing like the full coordinates of your graph, or if you wanted to zoom in on specific coordinate, which is pretty simple. But if there's like any questions about anything that was talked about previously, you could put it in the chat or any other kind of suggestions before we kind of wrap up. One thing I wanted to cover quickly about setting your own legend or your custom color palettes. Say that the way that the levels of your factor weren't stored in a way, like maybe things are misspelled or whatever, like something about how the data was recorded is not how you want it to be reflected in your visual. You can change this by using this labels argument. And kind of set, let's say one, or actually, let's say this was about just 3 penguins, Patrick, um, my last name for some reason, and Dave. The only thing is that how you set your, so the number of labels that you have within your concatenating object has to match the levels of your factor, and the order that your factors are reflected originally is the new value that is going to be adopted as. So the way that we see Patrick, Elie, and Dave set up is the way that they're going to be reflected in our legend. And so if I have this and it creates I was gonna ask this as a quiz question, but the reason why it creates a second, like we see that we have a new legend, right? It has our names, and again, it follows the same order that we had before. But the reason why it creates a second legend, which is something I had searched so much for why it happens, is because we have two things within our aesthetic mapping. So we have fill and color. And again, whenever we have, mapping like this within an aesthetic, it's going to create a legend. And so one way to get rid of the legend is to actually change the color legend, which is the species that's happening. We can, if I do no, it's just going to create the name, but we can use guides again, color equals null if that's, oh, not null, none. If that's not important, now we're down to one legend once again. Or if it is important that you do keep the color in a way, all you have to do is copy whatever you have in your fill and you change this into color. And as long as things are matching exactly the same between your fill and color options, why is it changing? Oh, sorry. Now we have to go back and change this to species once again. Again, we want it to be matching, and then it will resort back to creating one easy to follow legend. And so that is like, I would say, the key behind using things like scale fill. And it is the same if you use your own color palette or if you use one of the palettes that exists in R. So like kind of Scale Viridis, Scale Brewer is another one that is popular. But this, you have to have like a palette name. And unfortunately, I don't know all the palette names. I can do a quick Google though. And for people to kind of see, I think this was also shared in the repository, but this is like the palette name that I was referring to. So Scale Brewer, they have their own specific palette. And I think there are some that are like specifically colorblind within this as well. And the way that it's kind of organized is we have a kind of continuous color palette. So we're going from lighter colors to darker colors. We have a discrete color palette. So this is like more for categories. There's like no transition between colors. And this is like a divergent color palette where we have like a center point, and in each direction we're deviating from that center point in a way. And so for continuous variables, like these colors are good to use. For categorical, the discrete palette is good to use. And then for the qualitative palettes, and then for things like, say, Pearson correlation, are where you do have, again, a midpoint and you kind of want to show the extremes, that's when you would use the divergent color palette. And R, as long as your variable or you read your variable correctly into R, it'll map those colors, or it'll be able to adopt those palettes. So let me try to use, like if I try to use this is a continuous color palette, it's not going to work because, oh, actually it does, never mind. I mean, I wouldn't use a continuous palette for something that's divergent, but I guess it's a bit more lenient compared to like the Viridis color palette where you do have to, the C and D have to match what your variable type is. But yeah, so this just change it. Again, this, you know, these species are not continuous, which is why I would not use a continuous color palette to reflect this because they're just very different species. I think a common sort of color palette that is used is set one, and this is more clear cut, like 1, 2, 3, very simple, very clear cut. And yeah, all we had to do was change one line of code. And again, it comes with understanding that we have this mapping of aesthetics that happen in our box plot layer because we want each box plot to reflect each species that we have. And then this is how we bring in the scale to kind of change the color from the default R. Okay, and then yeah, the last thing that I want to cover now, and again, this is like very, you know, elementary focus. After the end of this, I have more, like I have this same kind of demo, but with more explanation of what's happening with each code that I'm gonna upload in the GitHub repository. So feel free to, you know, access that for what's happening here. But the last thing that I wanted to show was if this is especially if you have a scatter plot, and again, you kind of want to focus like on a certain section, or maybe you want to show like your scatter plot is getting cut off, but you still want to show the full range of what's happening. The way to do that is to use chord Cartesian. And this just creates a very like square, or like the full extent of, okay, this is, you know, the full range of your x-axis, this is the full range of your y-axis. But say that you wanted to kind of, you know, you're writing your paper, whatever, and you're like, okay, we kind of want to focus on like this specific value of x. You can just change that by adding this argument of the x limitation, and it'll zoom in your graph into the specific coordinates that you want. And for some reason, I just wanted to focus on the higher tail of my bill length. But if you wanted to go a bit lower, oh, this doesn't exist. You could do that as well. And then it'll move your graph accordingly. And that's, yeah, in the 5 minutes that we have, the last bit that I wanted to cover. But yeah, so we went over bar plots, histograms, kind of showed behind the scene. A histogram, it's just a bar plot with many, many, many bends, you know, used for for continuous variables. Then we went over box plots, and then we kind of, you know, covered, this is how you kind of change colors manually. This is how you change, you know, if you wanted to change the order of your legends to reflect, you know, whatever you wanted to reflect. These are the kind of layers that you go into doing it. We went over fill versus color, and this was just like a basic sort of scatter plot to just re-emphasize there's never too much data exploration when it comes to visualization. Not saying you should go, you know, run all the models and just poke around and, you know, like that's entirely different conversation, right? You should have a plan, an analysis plan, you know, a set for what you want to explore. But when it comes to just purely visualizing what's in your data set, kind of really understanding what's happening, what do things look like, this is just a place to start, and you can go on and on and on. And I think it gives a lot of insight to when you do go run some models and you do conduct your analyses. If something looks a bit wonky, you're, you know, getting results that you weren't really expecting, understanding what your data look like could again sort of provide a lot of insight into the results that you're seeing when you get into the statistical analysis side. And yeah, that is all from me. I'll be updating for those who were part one. There was a practice workshop that was given. I'll be uploading the answer key there. And if you want to have a chance of practicing with that practice sheet as well, feel free to do so if you have any questions. My contact information is there. But yeah, if in those last 2 minutes people wanted to ask questions or anything like that, again, I'll kind of upload a bit more extra materials to go into more details about some of these things. But thank you all for being here. Thank you all for your time. And so, yeah, I hope it was helpful in some way.